Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we will talk about the Akatsuki spacecraft and its studies of the planet Venus. So, Akatsuki, also known as the Venus Climate Orbiter, is a Japanese spacecraft developed by JAXA to study the atmosphere of Venus. Launched in 2010, Akatsuki was designed to investigate why Venus, a planet similar in size to Earth, evolved in such a dramatically different world. After an initial orbital insertion failure, Akatsuki successfully entered orbit around Venus in 2015, becoming a remarkable example of mission recovery and perseverance. The primary goal of Akatsuki is to understand Venus's atmospheric dynamics and climate. Venus has an extremely thick, hot atmosphere with winds that move far faster than the planet's rotation, a phenomenon known as superrotation. Akatsuki seeks to understand how energy flows through the Venusian atmosphere, how clouds form and evolve, and how weather patterns are maintained on a planet with no oceans and very slow rotation. Akatsuki carries a suite of cameras that observe Venus at different wavelengths, from ultraviolet to infrared. These instruments allow scientists to track cloud motion at multiple altitudes, study thermal structure beneath the cloud tops, and observe atmospheric waves and storms. Some wavelengths can even peer through gaps in the clouds to reveal surface temperature variations and volcanic heat signatures. One of Akatsuki's most striking discoveries was the detection of a massive planet-wide atmospheric wave extending thousands of kilometers across Venus. This feature provided key evidence for how energy and momentum are transported through the atmosphere. Akatsuki also improved our understanding of cloud dynamics, atmospheric circulation, and how solar energy drives weather on Venus. Observations suggest complex interactions between the surface, lower atmosphere, and cloud layers. The mission has provided new insights into how Venus's climate remains stable over long periods despite extreme conditions. Venus is often called Earth's twin, yet it represents a radically different climate outcome. By studying Venus's atmosphere, Akatsuki helps scientists understand the processes that drive planetary climate evolution. These lessons extend beyond Venus, offering insights into Earth's climate system and the atmospheres of rocky exoplanets orbiting other stars. The end of the mission finally came in May of 2024 when contact was lost with the spacecraft. So let's look at our conclusion here. And Akatsuki has transformed our understanding of Venus from a static cloud-covered planet into a dynamic world with a complex and evolving atmospheric behavior. Through long-term monitoring, the mission continues to reveal how extreme planetary climates operate across the solar system. So that concludes this week's exploration of the solar system on the Akatsuki spacecraft. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.